Alright, right now I want to illustrate how to go about solving systems of equations from word problems. We call it applications because it applies to real life. It's relevant to what you may experience or have experienced or will experience. Alright, here are some steps to guide you when solving systems of equations from word problems. When you read the problem, we need to define what the variables are going to be. The idea here is I want to have a system of equations to solve these two variables, to find out where they intersect, to find the answer to the question posed. Alright? So once we define our variables, it may be helpful to set up a table, and I'll show you more about how to do that. But the real goal is we want to write equations. A system of equations needs equations. The table is a way for us to write equations, but essentially we want equations. So if we don't use a table to write equations, that's okay as well. Some of the problems are a little straightforward or even a little complicated for a table. The third step is to choose a method and solve. So once we have our equations, we're going to resort back to what we've been doing with solving systems using substitution, elimination, or graphing to try to find where those two equations, which would be lines, would intersect. Okay? I'm not going to talk too much about checking your answers. I'll mention it, but I won't show you or demonstrate it to you. So let's start with something a little more straightforward. It can be quite abstract. It's not a super application. It's more just here's some numbers and here's how we start. All right. So this first problem, we're going to define our variables. It says the sum of two numbers is 70, and their difference is 24. Find the numbers. Well, when it says two numbers, it could be any number. And that should ring a bell to you to say, well, if they're talking about any number, great. We're going to use variables. Now you can use any two variables you want. You can use x, y, z. You can use alpha, beta. You could use a and b. Now I'm going to use a and b because x and y get overused, and it can be quite confusing. So a and b, any two random numbers or letters. You could have used CJ. Use your initials. That's fine. But the sum of two numbers, a, b, is 70. So instead of writing a table here, I'm just going to be straightforward and write the sum of a and b, the sum of my two variables, is, that's a fancy word for equals, 70. Okay? A plus b is 70. So that's the first equation. And there refers to the two numbers. So their difference is 24. So a and b's difference, that's subtraction, is 24. So remember, difference and sum, those are another words to describe operations like addition and subtraction. Well, now we got to choose our method and solve. So we defined our variables a and b. We wrote our equations. I didn't need a table to set that up. I just read it as it said it. And then we're going to choose a method to solve. So this is set up so well for elimination, it's hard not to use elimination. So I'm going to rewrite the equation over here so you can see how this is done. A minus b equals 24. A plus b is 70. Now, this is a positive b, or positive 1b, and a negative 1b. When I add those, I'm going to get 0. So this is great. I don't have to manipulate any of the equations even. 1a plus 1a is 2a. 1b minus b is 0b. And then 70 plus 24 is 94. Now I'm going to solve for a. 2a equals 94. That's 0. 2a plus 0 is just 2a. So 2a equals 94. Divide by 2. And you get a equals 47. Okay. Well, that's only half an answer, and we have to substitute that into one of our original equations to figure out what b is. I'm going to go with a plus b equals 70, just because it's all positive. A equals 47. Substitute 47 in for a. 47 plus b equals 70. And then subtract 47 both sides to figure out what b is. B must be 23. Okay? So that's our whole answer. It'd be 47, 23. Okay, because I got two variables, a and b. Alright? Let's try something a little bit more in line with an application, something you may actually see realistically. Okay, so notice I scratched out 6 here. It was just a little bit, it was a little bit more complicated than it needed to be. So we're going to go with 7. 7 will be a little bit more straightforward. And I'm going to do a different sheet of paper just so you can see that. Alright, so it says Carmen sold play tickets. Each adult ticket cost $4, and each student ticket cost $2. The total number of tickets sold was 260, and the total income, that means money made, was $700. How many of each kind of ticket was sold? Well, for number 7, first thing we're going to do is define the variables. Alright, so when we define our variables, what are the pieces that are changing here? Okay, adult tickets cost $4. Well, that's pretty set. $4 is set. But how many adult tickets are we selling? That's exactly what the question is. How many of each kind of ticket was sold? So I can assume adult tickets is one of the variables. Adult tickets. And then also student tickets. So adult ticket and student ticket. Those are the two variables. Those are the two changing values. Okay? So I'm going to use A for adult tickets and S for student tickets. And to further define it, it needs to be more specific. It's not the how much does the adult ticket cost or how much the student ticket costs, because that's already told to us. $4 and $2. It's how many, so the number of adult tickets. That symbol, although you refer to it as hashtag, it is also referred to as number or pound sign on the phone. Number of adult tickets sold. And then S would be the number of student tickets sold. Alright, so we have our variables defined. Now, we could use a chart, alright, and that's not too bad. So it says adult tickets and student tickets. So those are our two variables. And for this chart, we want two equations, okay? So right here, we're going to write totals. Because in the problem, we have two totals. We have tickets sold total and income total. Alright, so the first total is how many tickets were sold. Well, right here I have how many adult tickets were sold and how many student tickets were sold. And if I add those two values together, I should get how many tickets were sold total. That's considering there are no other type of tickets like children's or senior citizens and stuff like that. So we'll just say it's just these two. The other total we have is $700. Excuse me, I wrote that sloppy. Well, I know for every adult ticket, it's $4. And I also know for every student ticket, it's $2. And if I add those amounts together, I should get $700. Well, see, this is the table. This is a way I can figure out how to write my equations. This would be one equation, this top piece, and this would be your second equation, this bottom piece. I'll rewrite them so you can see them clearer. A plus S equals 260, and 4A plus 2S equals $700. Okay. Now you choose a method and try to solve. In this particular case, elimination may be nice. I could multiply this top equation by -4 so that I have -4A and +4A. Or I can multiply by -2 instead and get -2S and +2S. And then when I add them, it would eliminate a variable. Okay? And that's discussed further. So once you get to this point, it's a simple matter of choose your method, solve, and there you go. Okay, let's try one more. Let's try number 9. Okay, this one's a little bit more challenging. It says Anna has 4 times as many nickels as dimes in her bank. Her bank account contains $7.20. How many nickels and dimes are in Anna's bank? So again, here we're going to define our variables. Alright, so it looks like we're talking about nickels and dimes. Those are the changing values, okay? Because I don't know how many nickels and I don't know how many dimes. So here's nickels and dimes. Alright, and we're going to use n for the number of nickels, and we're going to use d for the number of dimes. Again, I know how much a nickel is worth, and I know how much a dime is worth. I need to know how many of each she has. So how many of each she has? How many of nickels, how many of dimes I have? I do have poor English, and it's my own fault. I will not blame it on the fact that I'm a math teacher. Alright, so Anna has 4 times as many nickels as dimes in her bank. So she has 4 times as many nickels as dimes in her bank. That means if I took the dimes, multiplied it by 4, that should tell me how many nickels she has in her bank. She says also her bank account has $7.20. $7.20. Okay? That means if I add up all the nickels, okay, and each nickel is 5 cents, excuse me, we're going to have to rewrite this. Okay, let's rewrite this. Alright, so we know that she has 4 times, so 4 times the amount of dimes will give her how many nickels she has. But we also know that for every nickel it's 5 cents, and every dime is 10 cents, and if I add up those amounts, I should get $7.20. Okay? So this is actually nicely set up to use substitution. So I can use substitution to solve this problem. And because it has decimals, I think I'll go ahead and I'll solve it with you. Or solve it for you in any case. Substitute 4d for n. Okay? So we get, I'm going to rewrite this bottom equation, 0.505 times 4d plus 0.1d. I just dropped that 0 because it doesn't make much of a difference, equals 720. Now I'm going to combine my like terms, or distribute first. So 0.5 times 4, that gives me 0.2d plus 0.1d equals 720. And then add those together, you get 0.3d equals 720. And then divide both sides by 0.3, by 0.3, and what you end up with is d, or the number of dimes, is equivalent to, and you can use a calculator here, or you can do this by hand. I hope I don't mess this up, but 3 goes into 7 2 times, 12, 3 goes into 12, 4 times, so there should be there should be 24 dimes. Okay, so that's 24 dimes. Now if I have 24 dimes, I can easily figure out how many nickels. So I'm going to go here, and I need 4 times as many nickels. So I'm going to go n equals 4d, or n equals 4 times 24d, and then n equals, well, 4 times 4 is 16, and carry the 1, 4 times 2 is 8, plus 1 is 9. So that means I have 96 nickels. Now, if we really want to figure out if this is right, you can take these numbers, 24 and 96, plug them in for your 2 original equations, which are right here. Plug n in for 96, and plug 24 in for d, and figure out if that's true. You could also plug it into the second equation, 24 for d, and 96 for n, and when you add them together, you should get $7.20. And that should work. That's how you check your answers. Alright, so if you have more questions, or you come across more applications that don't quite make sense, how you would construct the equations, by all means ask me in class, and we'll get that sorted for you.